Hello everybody, this is Haashini Sharadha Priya and we have done a project on microwave oven simulation and we are here to present our project. And my team members are Tharshana K and Sindhu K, and we are so glad to thank Emertxe for giving us this platform to do an internship on embedded systems. Let's dive into our project. Basically, what is a microwave oven? It's used to heat food or it's used to cook a food using electromagnetic waves. And in our project, we are implementing 4 modes and they are micro mode, grill mode, convection mode and start mode. In micro mode, we use a maximum power of 900 watts and it's a traditional way of cooking. So the maximum time we have set in our project for cooking is about 60 minutes. That's about 1 hour. Then we dive into grill mode. This grill mode is used to cook something like meat or bread. So in this type of cooking, the user needs to customize the input or customize the time taken for cooking the food. So in this grill mode, we can customize our timing in our project. Then comes the convection mode. In this convection mode, before starting the cooking, the oven needs to be preheated for just about 3 minutes and then it should start the cooking. So then comes the start mode. Start mode is used to start the function by the user. It could start a grill mode or it could start a micro mode depending on the user's need. See about what is embedded system, because our project is mainly depend on embedded systems, and we all know that embedded systems are used only for performing a specific task. If a device or if a platform can able to do large number of tasks, then it comes under general purpose system. So we have made a project, it could do a particular task, then it comes under an embedded system. Basically, an embedded system is a combination of any hardware or software which is intended to do a specific task. Then we are going to see what are the types of embedded system. We have basically 4 types of embedded system, that is stand-alone system, real-time system, networked system and mobile system. In stand-alone system, there are 2 types of systems, namely slave system and independent system. Slave system is nothing but it doesn't have intelligence or basically it couldn't bear many number of logical devices or decision making devices depending on the user's need. So it comes under slave system. Example for it, semi-automatic washing machine. Then we are going to see independent system. Independent system can take action by their own. It could have intelligence or it could bear many number of logical devices or decision making devices. So it's called an independent system. Example for it is Google Car. Then we are coming under real-time system. Real-time system can be basically known as time-bound systems or time-dependent system. If example for it is airbag system, in need of accident or in need of any jerk in the car, then the airbag system automatically opens up, and this type of mechanism comes under real-time system. Then we are going to see about networked system. In networked systems, the router, basically a router has some intelligence on how much data or which type of data must be delivered to certain part of network. So it possesses some intelligence. It comes under networked system. To see about mobile system. In mobile system, 2 major functions are going to implement it. One is intelligence and another is mobility. Along with the intelligence, if a device could move and deliver or make a decision in response to the surroundings, then it is called mobile system. An example of such system is a robot. Let's see what is a microcontroller and microprocessor. In embedded system, microcontroller or microprocessor is a basic logical unit or logical circuit unit which controls the entire function of the device or which going to take decisions on this device. It is an integrated circuit which is capable of performing a specific task. It has design restrictions such as memory size, input-output capabilities and peripheral function. Depending on these parameters, then we could conclude a device as a microcontroller or a microprocessor. Applications, performance, price, availability of tools and special capabilities. Depending on these parameters, we must choose what type of microcontroller or what type of microprocessor we are going to implement in our project. Then we are going to see about microcontroller. All components will be in a single chip and it's less flexible and it's less design complexity. That means it couldn't be able to support large type of user interfaces because these microcontrollers have less intelligence and less number of components used to accomplish the task. Microprocessor, all components are assembled separately and it's more flexible and it's more design complexity. In case if a device is going to do some image processing, then we need a component called graphical processing unit. Such type of components can be assembled used in microprocessor because these components are arranged in such a manner that it could fulfill the user's entire needs. These circuits have some complexity because more number of components are involved, and we have to ensure that it should work in accuracy, it should work according to its sequence. Then complexity takes place in microprocessors, whereas microcontroller doesn't need so much of components, so the circuit design's complexity is much lower compared to microprocessor. Then we are going to see about PIC simulation lab architecture. In our project, we have used PIC16F877A microcontroller. It's connected to RS232. It's basically a protocol used for serial communication transmission of data. We are using this port, we are transferring the data from device, say computer, to our microcontroller. Then the output device is LEDs and we are using buffer, digital keypad and SSD. SSD is solid state drives. It's used to store data. And the matrix keyboard where the tactile switches are arranged in rows and columns, and character liquid crystal display for printing the information. Then GPIO, that is general peripheral input output pins, and EPRO, electrically erasable programmable read-only memory. It's a non-volatile memory and a temperature sensor, analog to digital converter. Now we are going to see about syncing and sourcing circuit. In current sourcing, the device current flows out of the device. In current syncing, the current flows into the device. Then comes character liquid crystal display. In PICLAB lab, there are two types of displays, namely 16x2 display and 16x4 display. It displays the ASCII characters and some special characters that can be seen by users and can perform operations according to it. Then comes tactile switch. Tactile switch is a switch whose operation is perceptible by touch. The switch is used to select the mode of operation and is compatible for entering the temperature and enter time on how much time our project must be accomplished. This switch will produce a bouncing effect when the switch is pressed. Then comes matrix keypad. This is a keypad in which number of tactile switches are connected in row and column. This is used when more number of user inputs are required and still wants to save some controller input and output lines. These keypads are most commonly used in telephones, calculators. Then comes interrupt. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the microprocessor unit or microcontroller unit to stop the processing. Then the microprocessor unit or microcontroller unit acknowledges the request and attends to the request. It goes back to the processing where it was got interrupted. Then comes interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save registered contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it displays global interrupt enable. It places the address from the program counter on the stack. Then timer. Timer is an important application in an embedded system and default peripheral in a microcontroller, which maintains of an operation with the system time or an external time. It has many applications such as measuring time and generating delay. Calculate the timer count for the required delay. Set the pre-scale bits in T2 con register as per the delay calculations. Load the timer value into TMR2 register. So let's see our simulation of microwave oven. Here is the code and we have thought to write this code on the platform called MPX IDE. Now I'm going to open the PIC simulator. We have to set the clock frequency at 20 megahertz, and we should use a LCD display of HD 44780 at 16 cross 4. These are called tactile switches, as we already seen in my presentation, and they form the matrix keypad. And here is the PIC microcontroller, which controls all other components. Here is the EEPROM, and here is the cooler. This is buzzer, and it is the port for serial communication data transfer, and this is reset button. And as I already said, we have implemented 4 modes: microwave mode, grill mode, convection, and start. First we will see microwave mode. So I'm pressing first switch, then it shows power 900 watts, runs on 900 watts. Now I'm setting seconds as 33, and I have already implemented on my program that hash represents enter and star represents clear. If I press start, the second screen clears, and I enter some value as 30. I'm giving us an input. Then it asks me for start, pause, and stop. What's the purpose of start means? It sums up to plus 30 seconds. That means whatever the user gives, it sums up present value to the user's input value. If I give 5, then the process passes, and if I give 6, it stops. The microwave process stops. Then let's see about grill mode. Here also it asks for time, and I'm giving 30 seconds. When the process starts, here the cooler runs. It shows temperature of 27.50 degrees Celsius, and it shows timer that it would end up in 20 or 19 seconds. Okay, my cooking is done. So it shows on the display. Now I will show you the convection mode. As I already said, convection mode refers to preheating of the oven before starting to cook. If I give 100 degrees Celsius, it would heat up the oven to 100 degrees Celsius within 3 minutes of starting the convection mode. Then after attaining 100 degrees Celsius, the cooking process starts. Now I'm entering the input. So usually preheating done in 180 seconds, and within that 180 seconds, that is within the 3 minutes, it would heat up the oven depending on the user's requirements. After that 180 seconds, the required heating would be done on the oven, and we can set up the cooking time. Then it usually cooks the food. And preheating is done. Then it asks for set time for the cooking. I give 30 seconds, and I'm entering. Then it starts cooking. If I press reset button, then the microwave oven passes its process and comes to the starting stage, that is the initial stage before cooking. And that's all our project. Thank you for peacefully listening to our project, and I especially thank Emertxe institution for providing such a great platform to learn embedded system as an intern and implementing whatever we have learned as a project. It's an awesome learning experience through these 4 weeks, and had a very good live interactive sessions with the mentors. We as a team have learned a lot and gained fabulous skills to enrich our knowledge. Thank you once again, Emertxe Institution.